Attached to the flange of the gearbox output shaft is the prop shaft that runs back to the final drive. Most rear-wheel drive vehicles have their prop shaft divided into two parts because a long shaft will tend to vibrate. The prop shaft feeds power into the final drive, which is located between the rear-driven wheels.
On many rear-wheel drive vehicles, the final drive forms part of a single rigid axle assembly. This moves up and down with the suspension. The prop shaft must also move up and down, and so has a pair of universal joints which permit this movement.
In all cases, the final drive receives power from the prop shaft and relays it to each rear wheel via the drive or half shafts. On this type of rear axle assembly, these half shafts are located inside the axle casing. To redirect the prop shaft spin through 90 degrees, so the half shafts and rear wheels turn, the final drive contains two cogs. There's a small pinion on the end of the prop shaft. This engages with a larger crown wheel, and this is set at 90 degrees to the prop shaft and relays its turn to the half shafts and rear wheels.
This final drive has another important job. When a vehicle is driven in a straight line, both rear wheels turn at exactly the same rate. But going round a bend, the inner rear wheel naturally turns more slowly than the outer. It has less far to travel.
As a result of this, the final drive contains a device called the differential, which is designed to allow this. This differential is attached to the crown wheel in the final drive. Two small beveled cogs mesh with the two larger beveled cogs on the ends of the half shafts, the whole assembly rotating with the crown wheel. These small cogs don't turn at all when the vehicle is moving in a straight line. Power is relayed evenly to each half shaft and each rear wheel. But on a bend, the two half shafts must turn at different speeds, and in this case, the two smaller cogs revolve in opposite directions to allow for this. On a gentle bend, the cogs turn very slowly, but on a tighter bend, the greater the difference in half-shaft speeds, the faster they turn, splitting the crown wheel drive more and more unevenly. This reaches an extreme when one wheel loses its grip, in mud for instance. The spinning wheel absorbs all the power from the prop shaft and crown wheel. In fact, this is the disadvantage of an ordinary differential. All the power is taken by the wheel that's spinning, leaving none for the other. And we'll be looking at ways in which this can be overcome in the second program on transmission.